This data from the flipped classroom example will be used to illustrate how to use SPSS to conduct a one-way analysis of variance. You'll notice that there are three different teaching strategies for students to use when learning t-tests, and what the teacher was intending to do was use these different strategies for different groups of students to see which one might be more effective. And so these are the groups that the students are in, and these are their final scores on their t-test examination. And if you go to variable view, you'll see that each of the teaching strategies groups are labeled. So one, they used instructional videos. Two, they used videos and group discussions. And then group three, they used videos and group performance assessment. And so the teacher wants to know which one is most effective in helping these students to learn how to conduct and understand the concepts behind t-tests. So what we can do is we can go to Analyze, Compare Means, and then we'll go to one-way Anova. And in this case, our dependent variable is the measurement variable, so that's score. And then our teaching strategy is the factor or the independent variable. And remember, there's three different teaching strategies. And so we'll put that in the factor list. And under post hoc, this is the follow-up test, and it's done simultaneously. So what SPSS will do is, first of all, determine if groups do differ, and then secondly, it will conduct a post hoc test to determine which groups differ. And so you can see we have a wide array of post hoc tests that can be used for this purpose. And so I'm going to check the Tukey because it's a well-known conservative test that yields fairly accurate results. And so then I'll click on Continue. And under Options, I like to have the descriptive statistics because I want the mean and the standard deviation for each group, and then the homogeneity of variance test. And we'll talk about the homogeneity of variance a little bit in terms of Anova during our class. And then Continue, and then we can click on OK. And so you can see this is our output. And notice that we have the means for each group. So the instructional video group, for example, the mean final exam score for t-tests was 36 with a standard deviation of 16.465. And then you have the mean and the standard deviations for the other two groups. We can see with our Levine's test it was not significant. So what this means is that our variances, our group variances, are similar. So if we look at these standard deviations, and really all we have to do is square them to get the variances, we can see that they're really not that far apart. Now the Anova summary table, what this does is it tells us how much variability in these final exam scores that test t-test concepts, how much variability there is in those scores. So we have the between group variability, the within group variability, and then we have our total variability. And these are called the sums of squares. Now, the mean squares are determined by dividing the degrees of freedom into the sum of squares. To get the degrees of freedom for our between groups factor, it's the number of groups minus 1. So in this case, we have 3 groups minus 1 is 2. And so 2 into 2,240 is 1,120. So that's the mean square for the between groups variability. The within groups variability, again, we divide the degrees of freedom into the within groups variability of those t-test examination scores. And the degrees of freedom in this case are the total number of participants in our analysis minus the number of groups. So we have 30 individuals, we have 3 groups, so 30 minus 3 is 27. So 27 into 6,280 is 232.593. Now to get our F ratio, what this is really doing is comparing our sampling error or our random error to our variability due to group differences. And you can see that the variability due to random sampling error is much smaller than the between group variability. So if I divide 232.593 into 1,120, I get 4.815, and this is my F ratio. And this result is significant if we're using a 0.05 alpha level. Now, so we know the groups are significantly different, or at least 2 groups are significantly different. We don't know if all 3 groups are significantly different or not, and we don't know which groups differ. So we can come down here and we can look at our post-hoc tests. What the post-hoc tests do is it makes all combinations of multiple comparisons. So in this case, the mean exam score for instructional videos is compared to videos and the videos and discussion group. So in other words, if we come up here, we see this is the mean 36 as compared to the mean 40. So 36 minus 40 is minus 4. So there's 4 points difference with the video and discussion group mean being higher. And then if we compare the the instructional video group to the videos and group performance assessment group, we see that this mean is 36, and the mean for the video group performance assessment is 56. So 36 minus 56 is minus 20. Okay, so there's a 20-point difference between the instructional video group only and the instructional videos that use the group performance assessments. And so if we look at this comparison, we see that because it's above 0.05, it's not significant. If we look at this comparison, of course, it's below 0.05 and it is significant. Then then the next set of comparisons, this one is a duplicate. It's the same as this one here, but then the videos and discussion compared to videos and group performance assessment, there's a 16-point difference, and that difference is significant. And then these comparisons are redundant. So we can see that our instructional video group has the lowest score compared to the other 2 groups. And so there's a significant difference between instructional videos and the video and group performance assessment group, but not between the instructional video and the videos and discussion group. Okay. Also, there's no significant difference between the video and discussion group and the video and group performance assessment group. So the only significant difference we see is between instructional videos, that group mean test score, and the videos and group performance assessment mean test score. So this is how we look at interpreting and analyzing our one-way analysis of variance output in SPSS.